Okay, in the last one or two videos, you saw me express confusion that when I put a pair of 1 mega ohm resistors in parallel, so instead of having a 1 meg voltage divider, I expected to have a 500K 1 meg voltage divider. And then I looked at that with the analog discovery scope probe, and I saw lower voltage than I expected. And I thought, there's something that I don't understand. So as a matter of fact, there was something that I don't understand, and it's something that we saw earlier in the course. I believe that the input resistance of the analog discovery scope probes is 1 mega ohm. I haven't actually verified that directly, but I have some pretty good circumstantial evidence because I saw a significant loading effect when I plugged in the probe to observe the voltage when I had a 1 meg voltage divider, whereas I rebuilt this now using 100K resistors instead of 1 meg resistors. And I believe now that I get the expected result, which is here. So this little point should be 2/3 of the way between 0 volts and 9 volts, and so that should be 6 volts. And then I should be able to probe that. I'll probe it with the blue scope probe, which is channel 2. Now I go over here and I look at channel 2, and it says just under 6 volts. And if I look at just directly at the battery, oh, it's off scale. Sorry, let me change the voltage scale here. 2 volts. Okay, see, so that's just under, it's about 8.5 volts because the battery seems to be a little weak. So it's 8.5 volts, a little under 9 volts. And then I go to this voltage divider, should be 2/3 of that, and it's a little under 6 volts. So that looks pretty good to me. So, okay, so I was confusing myself because I was not accounting for the input resistance of the scope probe. I guess I've been accustomed to 10 mega ohm scope probes, and I think this is a 1 mega ohm scope probe. And I don't have a digital multimeter because I sent all my digital multimeters out to student kits. My new digital multimeter will arrive tomorrow, I think. Okay, now let me unplug this scope probe. Now I'm going to plug this biasing network into the gate. And then I'm looking, here's gate, drain, source, so then I'll look at the source. I'm looking at the gate and I'm looking at the source with the two scope probes. I have a better breadboard now too. The breadboard I was using earlier was too difficult to push things in and out of. Okay, now our waveform is 1 volt amplitude, which means 2 volts peak to peak at 1 kilohertz. Now I'll look at the scope probe outputs, and I see, I'm off by 1. There we go. Ha! Okay, I was plugged into the wrong pin on the breadboard because I'm old enough that my eyesight is not what it used to be. So this looks pretty good. So now I think you can see it's a pretty good follower. Here, let me just move this trace up by 2.5 volts. So instead of -3 volts offset, we'll do -0.5 volts offset. Yeah, and you can see they overlap pretty well just with an offset of 2.5 volts. So here, I'll go back to making it look easy to interpret. So you can see the separation between the two traces is a little bit more than the 2.5 volt V threshold. Okay, so I think I finally got things working understandably. Actually, one thing I want to do, and I'm going to do this live, dangerous as that may seem, I'm going to unplug my 9 volt battery, and I'm going to take this is the positive voltage source from the analog discovery board, and I'm going to go over to power supplies, and I'm going to turn on the 5 volt supply, and then I'll go back over to scope. Okay. So now that's not too, here, let me change the trigger level. Yeah. So now you see a slightly reduced amplitude, and also you see a little bit of distortion at the bottom because I guess it's basically being clipped a little bit at the bottom. And if I move this waveform, that's because I'm now, the gate bias is now 3.3 volts. You can see that this is about 3.3 volts instead of a little under 6 volts. So now if I move this up 2.5 volts, oh, actually, no, the amplitude's not really reduced. There's just a little bit of clipping. So that actually follows faithfully, except that it can't go below 0, which is familiar. So because our lower power supply is, we only have one power supply, it's 5 volts here. So going from between 5 volts and 0, so there's no way we can make the source go below 0, just as there was no way we could make the emitter go below 0. All right, so actually this seems pretty good now. Oh, I typed in the wrong number there, -3. Yeah, okay. So this is, I think, take 4 at this, and it seems somewhat understandable still. And again, this is more proof that all of this stuff is easier in Circuit Lab, and you can do it all in Circuit Lab.